Hi everyone, welcome back to my channel. So today we will be learning about comparison of concentration units. So when we say concentration units, we are referring to those units such as molarity, ppm, your mass per volume, or your mole per gram, and the like. So when we think of concentration units, we also recall the solution or types of solution. I'm just going to change the color. Solution. If you recall, we have a solution if we have a solute and a solvent. So solute plus solvent will result to a solution. So a solution can be in solid, liquid, aqueous or gas phase. So when we think of solute and solvent, an example would be a coffee powder and a a glass of hot water. So to remember this, think of the solvent as the you think the water as the solvent. So usually solvent are greater in mass than the solute. So that's how you identify if a compound or is solute or a solvent. So in this video we will be learning about the how to solve for the percent by mass, percent by volume, parts parts per million, mole fraction, molarity, and molality. So I think this will run more than 15 minutes, so there will be part 1 and part 2 for this discussion. So let's move on and start with the percent by mass. So suppose that we have this formula. We have percent by mass solute equal to mass solute over mass of solution times 100. So to get the mass of solution, which is the denominator here, it should be mass solute plus mass of solvent. So by the way, percent by mass expresses the mass of solute per 100 gram of solution. So this is constant. It is true and applicable for solution of 100 gram. So mass of solute per 100 gram of solution. Mass of solution is equal to mass of solute plus the mass of solvent. So that's here. So suppose that we have a sample problem. We have 30 grams of salt, NaCl, and 105 grams of solvent, which is water, H2O. So find the percent by mass using the givens. So we have 30 grams of salt and 105 grams of water. So we simply use the formula. We have first we'll solve for the mass solution. So what is the mass of the solute? Our solute here is the salt, the NaCl. We have 30 grams plus the mass of the solvent. As I said before, usually it is given in almost all cases. We have water as the solvent. So we have 105 grams. So the mass solution is 135 grams. So now we can solve for the percent by mass solute given the equation here. We have the percent. I'm just going to change the color. Right. We have the percent by mass solute equal to the mass solute. What is the mass of solute? We have 30 grams. 30 grams of NaCl divided by the mass of solution. The solution, we have mass solution equals to 135 grams. So if we have your calculator, this would be 930 divided by 135. You have 0.22. And note that we're taking the percentage, we times this by 100, so we have 22.2%. This will be the final answer. So percent by volume, we have if the solution involves a solute and solvent that are both liquids. So take note of this. The solute and the solvent should be both liquids, then percent by volume is used instead of by mass. So refer to the formula below. We have a similar formula to the percent by mass, and it's volume instead. We follow same format, but instead it should be given consideration that both solute and solvent are liquids. So for example, a sample problem would be let's say 50 grams of ethanol alcohol. We have C2H5OH. I think that's the ethanol. So this compound should be in liquid phase. And again, let's have 100 gram of solvent. We have H2O. So let's solve for the percent by volume solute. So first, let's use the second equation. We have volume solution given by the volume of solute. We have the volume of solute, we have 50 grams, plus the volume of the solvent, 100 grams. We have 150 grams of solution. So So take note that both are actually in liquid form. So the ethanol is liquid, in liquid phase, and the water is of course in liquid phase. So solving for the percent by volume, solute, we have the volume of solution 50 grams divided by 150 grams of C2H5OH and H2O. 50 divided by 50, have 0.33 multiplied by 100, have 33.3 percent. So these are the simplest example. We always have the water as the solvent. So the percent by volume solute of a ethanol and water, we have 33.3%. So next we have the parts per million. So this method is very similar to percent by mass. Instead of multiplying the ratio of the mass of the solute by 100, the ratio is multiplied by 1 million. That's why it's called parts per million. So the equation or the formula is also very similar to the percent by mass. So we have parts per million equal to the mass of solute divided by the mass of solution times 1 million. So suppose that we have a sample problem that asks what what is the concentration in ppm of a solution that is 0.00007% biomass solute. Hmm. So we will solve for the parts per million in this problem. So notice that the mass solute is given by in percentage form and not in grams. So to solve for the parts per million, we have ppm equal to the mass solute. We have 0.0000077% divided by 100%. So I'll explain that later why it is divided by 100% times 1 million. So this is equal to 0.77 ppm. So this is the final answer. So why did we derive from this formula? So we have 0.00077% divided by 100%. When what is asked is the mass solute divided by the mass of solution. So if you recall in your previous one, this should be, you should take note of this. So we say that we have any value, let's just say x percent by mass of a solution means that there are x grams per 100-gram solution. So the given here is percent by mass already, and this is always, the statement is always true. So the percent, x percent by mass of a solution means that there are x grams per 100-gram solution. So this we have 0.00077% divided by the 100% of, since we have 100 gram solution, and we should give this, if we have 100% biomass, this will equate to a 100 gram of solution. So the answer here is 0.77 ppm.